Solving one-step and two-step equations. An equation is a mathematical sentence with an equal sign that implies balance. That equal sign is very important. So if an algebraic expression does not have an equal sign, then it can't be an equation. Equations can be solved using a variety of strategies that focus on balance. In elementary school, you may have done some preliminary equation balancing using counters or even algebra tiles. When the equations are easy enough, sometimes we can solve them using a guessing and checking method. You may have been introduced to the concept of balance scales. And we're going to focus on the last two strategies using SEDMIB, which is reverse BEDMAS, and opposite or inverse operations. So the last two are the ones that we're going to focus on in our unit. So to solve an equation means to determine the value of the variable that makes the statement true by isolating that variable. And when we're using opposite operations, we must always keep the equation balanced. So that's why what we do to one side of the equal side, we have to do to the other side as well. So today we're just going to look at solving one-step and two-step equations. So we're going to go over some examples. Some of these examples you might be able to do in your head, but we're going to practice writing out the steps so that when we get to equations that are more complicated, you will have all of that important background and foundational skills to be successful. So when we're looking at this first equation, a plus 6 equals 18, we have to ask ourselves, what are we doing to the a? Because when we're solving equations, we want to get the a all by itself. So think back to when we did Pythagorean theorem, or when we were solving for area or volume. All of those were examples of equations. We were solving for something, and that's what we're doing here as well. So we want to isolate the a, so we have to move everything that's not an a to the other side of the equal sign. And it doesn't matter if we keep the letters on the left-hand side and the numbers on the right side or vice versa. You'll start to figure out which side to keep your letter on based on the value. So for this one, we're going to eliminate our 6. So we're going to move our 6 to the other side of our equal sign. So right now we're adding the 6. So the opposite of adding is subtracting. So some of you might remember writing out your steps like this, where we show that we're adding the 6 and then we're subtracting the 6. And then whatever we do to the left-hand side of the equation, we also have to do to the right-hand side of the equation. So we have to take our 18 and we're subtracting 6. So what happens is that our 6's are eliminated from the left-hand side, so we're just left with our a. And then 18 subtract 6 gives us 12. And so what we have now is our value for a. So a equals 12. And you may have been able to look at this and said, oh, well, what do I have to add 6 to in order to give me 18? That's 12. And you could have solved it that way. But this is a good strategy to get in the habit of, because when we get to more complicated equations, you're going to be very thankful that you know the steps. So now that we've solved the equation, we can verify our answer. And we do that by what's called a left side, right side check. So what we're going to do is we're going to break up this equation on the left side of the equal sign versus the right side of the equal sign. So on the left side of the equal sign, I have a plus 6, and on the right side of my equal sign, I have 18. So now I'm going to substitute in the value that I solved for 12 for a and see if the left side equals the right side. So I have 12 plus 6, and 12 plus 6 is 18. Look at that, they're both exactly the same. So now we can write, we know when the left side equals the right side, we know we haven't made any mistake. So now we can say with confidence, therefore, a equals 12. Sometimes you may also see this expression written as the left side equals the right side, therefore a equals 12. So if you show this work, then you can write this statement as well. So let's take a look at example 2. Example 2 is b minus 4 equals 12. So first ask yourself, what is being done to this b? So right now we are subtracting 4 from b. What is the opposite of subtracting 4? That's adding 4. So I'm going to add 4 to both sides. So I'm going to add it to the left-hand side of the equal sign, and I'm going to add it to the right-hand side of the equal sign. So my 4's are eliminated from the left-hand side because negative 4 plus 4 gives me 0. So I'm left with b equals, and 2 plus 4 is 6. So let's go ahead and do our left side, right side check. So the left side is b minus 4. The right side is 2. I'm going to substitute in the value for b. 6 minus 4, and 6 minus 4 is 2. Look at that, they're both the same, so I can say the left side equals the right side. Therefore, b equals 6. And so this just gives you some assurance that your solutions are correct. So right now, when they're easy, the one-step equations, it might not seem so important, but like I said, when we get to those more complicated equations later on in the unit, you're going to be thankful that you can check your answers to make sure that you get it right, especially when you're doing a test or a quiz or any sort of assignment as well. Example 3 is 5c equals negative 20. So again, we want to isolate c, so we want to get c all by itself. So we have to ask ourselves, what operation is being done to the c? When I have a number, which we call a coefficient, directly beside a letter, which we call a variable, that means that we're multiplying. So the opposite of multiplying is dividing. And you can show the division using a fraction, or you can use a division symbol. I'm going to show it as a fraction. So I have 5c, so 5 times c, and the opposite of multiplying is dividing. So I'm going to divide by 5, and that's equal to negative 20. And I also have to divide by 5, because whatever I do to one side, I have to do to the other. So 5 divided by 5 gives us 1. So we're left with c on the left-hand side. And negative 20 divided by 5 gives us negative 4. So now we can do our left side, right side check. To verify our solution, the left side is 5c, the right side is negative 20. I'm substituting in the value of negative 4 for c, and 5 times negative 4 gives me negative 20. The left side does equal the right side. That's what I want to see. So therefore, c is equal to negative 4. We're going to go through one more one-step equation, and then we're going to do a two-step equation. So example number 4 is a division. So anytime you see a fraction, that means division. So what am I doing to the d? Well, I'm dividing by negative 3. The opposite of dividing is multiplying. So I'm going to multiply both sides of my equation by negative 3. So whatever sign is with your 3 or your number, you're going to use that sign as well. So I'm going to show this by using brackets. So negative 3 times d over negative 3 is equal to negative 3 times 5. So I'm multiplying both sides of my equation by negative 3. And negative 3 divided by negative 3 gives us 1. So those cancel each other out. So we're left with d. And that's equal to negative 3 times 5, which gives us negative 15. So let's just check to see our work is correct. So the left side equals the right side. Well, we don't know that yet. So we're doing the left side, right side check. So the left side is d divided by negative 3. The right side is 5. Our d value we chose was negative 15. That's what we solved for. Negative 15 divided by 3. And that gives us negative 5. So that's exactly what we had. Sorry, that was a negative 3. So that's positive 5. because a negative divided by a negative is a positive, and the left side equals the right side. So now we can write our statement. Left side equals right side, so therefore D is equal to negative 15. So those are all examples of one-step equations. So those are probably the simplest types of equations that you're going to see. When we get to two-step equations, it's exactly what it sounds like. So we are doing two things, two operations to our variable in order to get our final answer. So this is where the reverse BEDMAS comes in even more importance when we're looking at example 5. So first of all, we want to get our E all by itself. So we want to isolate the variable. But in order to do that, we have to do what I like to call reverse BEDMAS. So I'm going to write my BEDMAS acronym along the side here, and I'm going to go in the opposite direction. So now I'm going to start with subtraction. So do I have any subtraction? No. So then I move on to addition. Do I have any addition? Yes. So right now I'm adding 4 to 2e. So the opposite of adding is subtracting. So I'm going to subtract 4 from both sides of my equal sign. So plus 4 minus 4 gives us 0, so those are gone. So we're left with 2e, and equal to 12 minus 4 gives us 8. So we've done subtraction, we've done addition, so now we're moving on to multiplication. Am I multiplying anything by my e? Absolutely. So the 2e means 2 times e, so I have to do the opposite of multiplication, which is dividing. So I'm going to divide both sides by 2. And some people will show that right here, like use this same line, but if you wanted to show it on a separate line, you can. So some people will turn this first, like this second line here, into those fractions. So 2 divided by 2 gives me 1, so those are eliminated, so I'm left with e. And then 8 divided by 2 gives me 4. So I did 2 things to find my final answer. So first I had to subtract, and then I had to divide. So I was doing that, solving my equation using reverse BEDMAS. So let's check to see that our solution is correct. So the left side and the right side. The left side of my equal sign is 2e plus 4. The right side is 12. So 2 times 4 plus 4. 2 times 4 is 8, and 8 plus 4 is 12. So the left side does equal the right side. That's what we want to see. So therefore I can say with certain that E is equal to 4. And that's how we solve one-step and two-step equations. You may remember this from not only elementary school, but also from grade 9. You would have done lots of solving equations of grade 9. And so this is just a quick recap and review using the methods that we're going to stick with throughout the rest of the unit.